All right. So today we will look at the conditional statements. Conditional statements. And also together with the looping iterations. All right. Uh, so lecture goes fast, but we will do practice, not only in class and also the homework assignments. So I want you to practice the data types, conditional statements, and iterations, all of those extensively, so that you can prepare for your midterm exam. So today we will finish up conditional statements and iterations, and then I will give you an assignment, which is the last assignment before your the midterm exam.
Okay.
I will give you about a week, so that you need to submit it. Yeah, around this time next week. Next week will be the lecture before your midterm exam, right? So next week I'll give you um, the review and take questions if you have. So we'll do that next week. So pretty much, hopefully, I can finish all the lectures today. So next week will be somehow the wrap up and review that would help you to prepare for your midterm exam better. So you have enough time. Okay, conditions. What is a condition? If you look at the dictionary, condition is the state of something with regard to its appearance, quality, or working order. So it gives you some hints. What is conditions? Then how can we describe condition in coding, and how the conditional statements behaves in programming? It is similar to the way there is a data flows from top to bottom. So data comes in, and there is some the evaluations, some conditions. The result of that evaluation is true, then it goes to another module. Otherwise, it goes to the other modules. That is the behavior of conditional statements in codings. So knowing that behavior, then how can we describe conditions? Condition is a statement that can be evaluated. So conditional statements will split the given world, into one or more sub-worlds. So conditional statements branches the flow of computations. For example, this is the language, so that you need to describe if and else statements. If followed by conditions that you need to describe, colon. Colon is important in Python. So whatever you describe between if and colon, that is the condition. So condition will be evaluated. If that is true, then the following, after this colon, whatever written, that is the action to take. So that is action. And anything that you need to do, describe actions, but you can describe more than one actions here. Remember that the Python is the case sensitive and indentation sensitive. Anything then you describe, even if those are multiple lines, if they are all lined up with the same indentation, then those are all the actions to take under the evaluation of this condition to be true. Otherwise, then the following, if you want to do some other actions, the other case, then you need to say here else. So else is another reserved word. This else should be the same indentation with if. So if and else, same indentation. And then colon. After the colon, any statements with the indentation with this else statements, whatsoever the indentation, it doesn't matter how many spaces, but the same indentations. If we have a list of actions, those are all the actions needs to be taken for the case of else. Okay, that is the things that you need to do. So in this case, this condition can split into two, right? The case of true, case of false. We can make this multiple nested version. So if given condition 1, then we can take multiple actions for the case of condition 1. Else if, we can make another condition. Then we need to say elif. Some other language, it says else space if, but in Python, make it one word. So elif, followed by condition 2, colon, followed by action for that condition 2. We can keep doing this. Elif condition 2, elif condition 3, elif condition 4, 5, 6. And then finally, otherwise, if any cases doesn't make all the conditions beforehand, then there is a case here. There's else. And then finally, final action. Okay. So example for that is here. If you have, for example, range, age greater than 21 or less than or equal to 36, then you need to specify in this way. This is very handy. Some other languages does not support this, but Python. If it doesn't support, then you need to go this way. You need to make only the one operator, two operands, because this is a binary operator. So operand 1 and operand 2. First operand should be greater than or equal to the second operand. So this condition, one condition can describe only the case of this. But if you want to describe the range, then we need to bring up another condition. So this is lower bound, this is upper bound. Upper bound will be yet another condition, and those two conditions needs to be connected. So that connector is the end, the connector symbol 2 n% like this, or you simply say and, A-N-D. There's our language, right? A-N-D. That should work. You can combine these two like the first statements here. This is a more mathematical form, right? Like this. So with that example that we already looked at, therefore, The format of conditions can be formed in this way. Operator in between, and then we could have two values or one variable and one value or two variables, or simply a variables or value if that is a Boolean value. They are possible, right? Age is greater than or equal to 21. Height is less than or equal to depth. This is a variable and variable. And the red lights, if it is true, then it means the red light. If it is not red light, then this variable becomes false. So it gives the evaluation of that variable is false. So conditional statements is can be evaluated. First of all, it should be variable should be evaluated if there is a variable, right? Variable should be evaluated. Simple condition is like this. If and data is greater than or equal to 21, colon. So this is a conditional statements, conditions. In order to evaluate this, we know 21 is a primitive value, that is a known value, 21. Data that is not known, this is a variable. This variable should be evaluated. Then you need to go up, see if data is already defined. So data is defined. Data equals right-hand side. So right-hand side needs to be evaluated. So whatever the result of this evaluation will be assigned to the left-hand side. Right-hand side, by the way, here, that is a function, input. Input function gives you prompt statements so that user can respond to it. So what it does here is to enter your age in integer. So you can put enter here, your integer, right? From your keyboard, that is called the standard input. So using your standard input is a terminal, the keyboard. There are many other types of inputs in different devices that you can enter the input, right? Audio, that is the input, or camera, that is also input, or internet data provider, that is also input. But anyway, this is from keyboard. So user can enter, say, 19. This is input. But we have to do something here, right? This is not going to work as is. We already looked at. If you do not know what it is, then you have to go back the previous lecture and find out what additionally put here in order to prepare for your midterm exam. But anyway, whatever the integer given and assigned to data, and that the result of that evaluation is nothing but this data. So that is this data, the number here, and the primitive number 21 compared. So we know the result of this conditional statements evaluation. Depending upon that, either we do the action that comes immediately after this colon, or there's an else statements, so that is the action to be taken if this condition is not true. Oh, I already, yeah, okay. Connections. We could have a connection here, right? If we have more than one conditional statements needs to be combined, then you need to have a connector. So this is AND sign. OR sign is to vertical, or you can simply say OR. Literally OR, literally AND. Those are the keywords preserved by Python, so you can simply use it. That's fine. And equal sign here, that is an assignments. Double equal sign means that is the equality checking. If you want to check the equality between left-hand side and right-hand side, then you need to use double equal sign. Double equal sign is not an assignment. That is mathematical equality sign, right? So condition can be used in based upon the data type that we looked at. For example, this is a list. A is a list, 1, 21, 5, 3, and then we can access any specific value within the list. So if you want to access second item in the list, then you need to say A within square bracket index 1. Index 3, then that'll be the fourth element in the list. And you need to compare. Remember that this is the operator. This is a conditional statements. This conditional statements needs to have specific value. If this is a variable or this is not the primitive value, then it should be evaluated. So A square bracket number 1 close square bracket, then you need to access that list and get the value. Same thing here. And then you can see whether the result of this condition is true or false. If it is true, then A dot insert. Then you need to insert into the index 1. This is index 0 and this is index 1. If you say index 1, then before that, in between this. So you want to insert into this A3. So the fourth one will be inserted here. Fourth one remains still, but you want to insert one additional. That is what it is. Otherwise, print all. So question is, what is the output? It says print A. We have to first see the condition here. A sub 1, which is 21. A sub 3, that is a 3. 21 is greater than 3. Therefore, this is true. Because this is true, then we need to update the list by insertion. So inserting this fourth element, 3, and then insert into before this index. And after insertion, that will be the index of this value. So 3 comes here. So 1, 3, and 21, 5, and finally 3. That is output. Can we remove the last element 3? There is another method, function, already associated with the list. There's called the pop, right? Then you can remove. There is another see here, help, then list, then there's a pop, index -1, remove and return item at the index. Default is last. So if you don't say anything, just pop, then the last element will be popped out. It says remove and it returns that value, remove the value. There's another thing that you can see here, remove. Okay, that remove, if you say this is a remove, where's the remove? Remove, yeah, remove and value. If you say value, then this removes the first occurrence of the value. So you need to understand what remove and what is the pop precisely. So if you want to, after this, the conditional block, if you want to remove the last elements, then after remove, if you want to remove the last element, then you need to use a pop rather than remove. If you use a remove, then it'll be removed the one that was just inserted, not the last ones. So you can do further, yeah, pop. We looked at that. That is explained. More and more, this condition, if this condition is true, followed by colon, followed by a block. This is an action block. Anything listed in this block. Why this is action block? Because they are all aligned the same indentation after colon. So if this condition is true, then all of this in this sequence needs to be taken. And finally, this print statement is not within this action block, but this is outside this if. So this in the global the order, the list declaration is the first statement. Second statement is if statement, if and action statements, and third statement is print statements. So this print statement has nothing to do with this if and action block. Okay. So actually, in the global level, 3 statements: the list declaration and if an action statement. Third one is print statements. You can make it in conditional. You can describe conditional statements over dictionary. So this is a dictionary. Age, GPA equals John's GPA 3.7, Sam's GPA 3.1, Adam's GPA 2.5, Peter's GPA 3.3. Remember, this dictionary is a key and value pair. In between, we have a colon. This is one pair. There's a delimiter comma. So that second pair comes. So first pair of dictionary is John's GPA is 3.7. Second, I would not say second. There's no order, right? There's an unordered list. Dictionary is an unordered sequence. Unlikely list or tuple. Dictionary, we can identify the value by a key, not by an index. So that is thing here. GPA dot get. Get is a method. You can get Sam's GPA by using get, or simply you can do GPA square bracket Sam. So, for example, here, dictionary, then there is a get. Get, if you give a key, get, and if you give a key, then it returns the value of the key if key is in the dictionary. Otherwise, it gives an else, default, if you specify default. So what I will do here, this is homework number 4, and then GPA equals, I want to get, this. This is not. Okay, here. Yeah, this is the dictionary. I want to make another one here. Where is it? Yeah, maybe here. Maybe here. We're going to work on this a little later. So print GPA dot get Sam, then we can print that, or you can do another way, GPA. Either way will work, right? So if we do this, we have to quit. Okay, this 3.1 is a Sam's GPA. You can access the value for the key. You can get it using a method. Or simply another way, I would just say, using that square bracket. If we use a square bracket in a list, then we need to put their index number. Index number goes into that square bracket when it comes to a list. The key can be in that square bracket for a dictionary. That's what it is, right? Okay. But anyway. So dictionary. So we can compare, because in that way, Sam's value and Adam's value can be accessed. So these conditional statements can be evaluated, because this can be evaluated by the invocation of this method get. Then we can get 3.1 value, and then another one for Adam, and then 2.5 can be the result of that evaluation, and those two values to be compared. Depending upon the result of that, then we can do the actions. There are two print statements. First print statements all the way to here, and then this is the second print statements. We already looked at this format, right? And if we say and equals anything that comes in the end, right? If we don't do anything but only no blank. If we don't say and, then default value for this is new line. But if we want to replace the new line with the value we explicitly specify, then that is whatever that is, that replace the new line. So instead of a new line, which means on the same line with no space, next the print statements comes. It is another way that you can access, right? Page on. Connecting conditions, you can connect more than two. I mean more than one. So two conditional statements combined with the and. This is a connector. So you need to specify, you need to evaluate state, if state equals New York. If state is New York, then this is true. So each of this can be evaluated. If this is true, and if you say, if you connect the evaluations, conditions with and, entire will be true if each one of these is true because of this and. Okay, all of these conditions needs to be true. Therefore, all those come connected by and, the entire result will be true. Any one of a condition is false, then entire will be false. Right? So for example, if true and true, this is possible, right? So if you execute this, then that's true. Because everything of this, here is the AND operator, and. All of this operand needs to be true. Then it'll be true. Any one of these false, then entire will be false. Any one of these. Doesn't matter. Any one, right? In order to make it true, then all needs to be true. But on the other hand, this is AND case. False case, OR case, or oops. Then of course this is true, right? This is also true because if we have OR, then any one of those are true, then that will be true. For example, first one is false, second one is false, third one is false. Any one of this is true, then entire will be true. So this second one will become true. First one, of course, will become. Both will be true. If you run it, both will be true. Or case, if everything is false, then it will be false. Because it says any one of the condition in the or connectors is true, then it will be true. If everything is false, then that, of course, then that is false. Then it will be false. Any one of these turn to true, then it will be true. Any one of these turn to false here and the case, then it will be false. So what is the answer? First one will be false. Second one will be true. So that is the case here. We could have a multiple conditions. If, elif, 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 finally else. So condition and actions can be listed. Okay, this is conditional statements. And then we will continue to do the loop, iteration. Iterative operations are needed. Why? One of the benefits of the coding is to make predefined procedures as many times as required. If it is some small number of iteration, then we may not need computers. We can do it manually. Many cases. But if we have, for example, I want to do this 1,000,000 times, then manually almost impossible, right? It's not possible, but if we do manually, then it takes time. If we want to make it quick, then we better use computer. There are so many cases that you can think of. Cyber security examples, forensic search rules. If you want to find, for example, some if you want to find somebody, some criminals from the surveillance camera images along the streets when something happens. Okay, so think about criminals took place last night at Manhattan, some street, and then in Manhattan there are millions of surveillance cameras running. But that for example, murder. Somebody's dead. So murder well, trying to find the murder. We do not yet who is the murder, right? So there are, let's say, 10 uh, possible candidates so that we want to chase. We do not know what that person is, those peoples are, but we know there are 10 people uh, found near that crime scene. So from there, we chase each one of those. So one person goes to east side, one person goes to north side, the other maybe go downtown, the other maybe goes to west side. Each one dispersed along the streets, along the avenues. So we need to chase the cameras, uh, 10 people, all different directions, chasing, looking at the camera. There are tens of people on the camera scenes. So chasing is almost impossible, right? So in that all situations. But if we have good, supposedly good image recognition tools so that we can run it, then it can anyway chase on behalf of humans manual chasing mechanisms more efficient, more, I mean, of course, automatically. That's possible, right? Probably I picked very complicated examples. But for simple examples in cybersecurity, if you want to find some keyword from the documents, then you can search that keywords in the documents using the program. That'll be for loop. Then it'll be faster and easier, automatically. If you find it by using manual tools, for example, Control F for finding. So one time you find and goes to next match and another match, another match. If you have a million pages of documents, then it takes longer, right? So that type of things is an example. So iterative statements is really needed. How can the same code segment can be performed iteratively? Can be based on for a number of times. So we can specify, do this 15 times. Or sometimes we can say, we can give a closed world, say data types. Given data type, remember that, given this, you need to search whatever within this, the closed world. Camera, if you want to chase some potential murder over surveillance camera images, is it closed world or open world? It is a big world, but still that is a closed world. So it is possible, quite possible, right? If we want to find something from files, then that is also closed world. If you give websites, that is a big world, but still that is a closed world. If website is dynamically evolves all the time, yes, then that is kind of open world. But if you set the time, I wanna look up the web pages up to this time, up to this timestamp. then that is, of course, closed world. It may be open world. It is because time still continues, right? It's not ended yet. That is the reason. Another thing is while we can give some conditions. So I want to do this while, as far as something goes on, I want to repeat this. We can make our statements iterative using some conditions, while loop. There are many ways that you can describe, right? In this multiple different ways of iterative statement descriptions, the language supports this. So Python is not, in many cases, the language specification-wise, Python is not really solid and rigid and stronger than not powerful in expression compared with the other formal languages like Java or C, C++. But the iterative statements is okay. For loop, little less power. But in general, in any case, I don't see Python is insufficient. Although language does not support, still we can make it in another way. Loop iterations, given from this, we can do multiple circles. So sometimes this is circle scope diminished, smaller and smaller, and finally can terminate. Or it can grow and grow. And then if there is a limit, if there is a closed world, then, hey, you looked at entire of my searching space. Excuse me. Then there is no space that we need to look up. That's entire. And then there is another way this loop can terminate. Two extreme cases of termination conditions, right? Can be smaller and smaller. So nothing available. This is bigger and bigger, fully considered. Iterative statements for a number of times, for each in a given list, for each element in a file, while some condition is met. Each one of those can be described in language. For example, for a number of times, then you can say for each in range 1, 5. Range 1, 5, if we say range, then it returns 1, 5. Let's say this is still that. For I in print I, then it'll be you want to print I. What is I? I is a variable declared in this for loop for variable in the range. This range starting with 1, ending with 5, but 5 is exclusive. So it'll be 1, 2, 3, 4. That's what it is. This followed by, there's a variable. That is your local variable. I use another variable I, and that is used here. In this case, each and each. For each inner list, you can describe it. List LST equals, this is a list of those, right? For this list, you can say your iterative statements is this. For each in this list, LIST, you want to print each. Okay. Each, the variable each is a local variable. You just declare it within this for loop, and you use it. Same thing like this, right? So in this case, you can simply do for each, you can say EA in A, and then print A. That is also possible. So this can be run by alt return or option return, like this. You want to print this. You want to print in this list, take one at a time. How many elements there? 4 elements. One at a time. But you want to print A itself rather than EA, each. But if you say here EA rather than E, then you will have this. Remember that this previously I said E, simply A. I want to display entire list. How many times? For the same number of times as the number of elements there. Because there are 4 elements, so for 4 times, I want to print entire. There's an earlier version. Right now, this I want to print that element itself. In the first print statements, prints 1. Second print statements prints 21. Third print statements print 5, and then finally 3. Because this for loop runs within that range. Range is nothing but the list itself. Right?
Professor, I have a quick question.
Sure.
So with this compared to the one you did before, the range 1, 5, so that one prints everything up until the last value, but this one prints everything?
Right. This one does not say that comes from that the characteristics of this function range because of that function.
Okay.
Because of that. Yeah, that's a good question. That may be confused to you, right?
Yes.
This is a list itself.
Okay.
Range gives you only 1 to 5. Let's say help. If you do range, let's see how it describes. Okay, class range. return an object that produces a sequence of integer from start inclusive. From start to stop, that is exclusive. By step. Make sense?
Sorry, can you repeat that? My internet went out for a little bit.
Huh?
Sorry, please, can you repeat what you just said? My internet went out.
Oh, is that right? Yeah. I just refer to the library or help range. When I type help, then it gives you the description about the help. So this is class help, class range. It says returns on objects that produces a sequence of integers from start point, whatever you say, range and start. It includes inclusive start all the way up to the exclusive stop. That's what it is.
Okay.
So
Thank you.
let me redo one more. For a in range 1, 7. Then it says, oops, I want to quit this help. So 1, 2, 3, 4, 5, 6. This is a start number. This is a stop number. Start and stop. This is a second number. Inclusive, the first number. It goes by integer, by step, till the stop number, the last number, but that is exclusive. So from it gives you, it returns start number by step. So it add one more integer all the way up to this stop number. So when it comes to this stop number, that stop number, there we stop it. Exclusive, that number exclusive. So up to this 6, we do not know whether it will stop. When it comes to the last number 7 here, therefore we know that we stop. And the very number 7 will be excluded. Okay. So if you want to make the sum, I want to make sum from counting from 1 to 7 exclusive, then you need to do here sum plus equal 1. And then finally I want to make sum here. What is this? Oh, because I made the wrong key. So option and to this. So number 6. Oops. This is nothing but sum equals to sum plus 1. Oh, not 1. We need to put a. Right. So say that is 21. What it does is that given sum equals 0, so you need sum plus equal, this is somehow composite symbol. What this symbol can be interpreted, if you have sum plus equal a, there's nothing but sum equals sum plus a. Mathematically, this doesn't make sense, but in programming, what it does is this equal sign is assignments. So right hand side first needs to be evaluated. So current sum plus a. At the very first time, sum equals 0, and then a is from this range function, first return value will be the start number here, 1. So that will be 1. So sum plus 1, 0 plus 1. That will be assigned to sum. So it will be 1. At the end of this statements, sum is updated to 1, not anymore 0. For loop iterates within this for loop, not this sum. So sum currently 1. And in the second iteration, range returns second value, which is 2. So a becomes 2. Sum, so this is nothing but sum plus a. A is 2, sum, the very previous value is 1. So 1 plus 2 equals 3. So sum is updated to 3. Okay, all of those can be written in a way like this. Sum plus a equals that format. So first value is a sum. And second value is a. I should not do this before that. I need to do this after that. And I'm not going to do this. I want to make this hold. And I want to make this E and D equals. I do not want to make a new line, but I want to do print statements further. Print format and then sum here. This is a very good example, by the way, right? This is a very good example. From 1 to 7, 7 exclusive, I want to add them. I want to print sum plus a, like here, sum plus a, the right hand side. Sum plus a, so we put sum, first placeholder, second placeholder a, and equal. And then rather than making new line, I want to stay in that on the same line. And then I compute this. So sum will be updated. That is the result of that sum. That is printed. Okay. So I don't. Okay. So if I run this, then it will be this. Initially, sum is 0. And a is 1. Remember that here, second one, it increases from this range. So 1, 2, 3, 4, 5, 6. So sum equals, so first print statements, and then computation, followed by the rest of the print statements. there I want to print the result of this computation. So 0 plus 1 equals 1. 1 plus 2 equals 3. So it can be do this all the way within this for loop. After this for loop, I said here, print sum. Finally, one more print. Sum only, the last result, 21. That is printed. Right? You can do this. I want to count from 1 to 10. I want to sum from 1 to 10. What is the number? I know that. So 55, right? So you can do simply, because 10 is not exclusive. So if we put here 11, then that is 55, right? You can do the same thing, for example, 101. What is the summation from 1 to 100? I do not know. So let's do that. 50-50, right? And here, range has another parameter. Oops. It gives you here some hint. Let's do here. Range, and then here, didn't give to you. If I want to sum only odd number, even number, from 1 to 100. So for example, 2 plus 4 plus 6 plus 8 plus only the even number starting from 0 to 100. So I need to say here 101. 101 is exclusive. And run it. Then that is only odd number, right? 2, 4, 6, because I said here 2. If we want to make it even number. If you want to make odd number only, then you can start from 1. Oh, sorry. Then 0 plus 1 equals 1, 0 plus 3, 1, 3, 7, whatever the number, till that, right? You can make this every 5. From 0. So 5, 10, 15, things like that. Then it'll be 5, 10, 15. There's a 10, 50. You can make very interesting result, right? Or if you want to make how many iterations? How many iterations? Then you need to put here, there's another function called enumerate. What enumerate returns is the count and the value itself. So that we can say here count. This will returns, enum returns 2 values in tuple. So enum range 1, 5, that returns enumerate. Enum is not working. Enumerate works. So here we need to say enumerate. So what it returns is only that. So if we want to print it, same thing.
Professor, when you wrote enumerate, there's an error there. I think you wrote it twice.
Oh, there is another. I was trying to see this. Enumerate, yeah. I want to demonstrate to you here how it works. Let's see if I do list, then you may be able to see what it is. Yeah, you may be able to see it. This is what this enumerate returns is two values. First value is a count from 0. So 0, 1, 2, 3. There's a count. And the second value is the value from this range itself. So to make it more clearly, then you can start from 10 to 15. Clearly see each tuple here. First value is the count. Second value is the number returned from this range. So the range 10 to 15 returns 10, 11, 12, 13, 14. So 11, 12, 13, and 14, right? First value in a tuple, because it returns, if you say enumerate, it returns two values. First value, simply count. 0, always from 0, 1, 2, 3, 4, whatever the count that is. So I can do here C and T. What I want to do here, I want to make, watch this. And then first one is count plus 1. Okay, so I want to run that. C and T. It counts first iteration 1, 2, 3, 4. How many iterations? 21 iterations. So we can say here, question is how many iterations? Then we simply say, oh, there's a 21 iterations. What is the result? So what is the result? Result will be 10, 15, right? This. Okay. So that is each list and each element in a file. That is also possible. If you open a file, this is a new. You guys never had this yet, right? So with open and file name as F for each, in that F is a file because you open a file. F is a file. File, what is a file? File is a list of word, right? Each word. So each word will be printed here. That's what it is. And then for while loop, there is also possible. So while true, you can while true and colon. This while loop is a new. This is a loop. So far we have a for loop using for followed by variable in some of the set. But in this while loop, while and condition, but condition is already evaluated, so you say true. So this while loop always true. So always whatever within this, the body continues. But in this body, there is a if statements. If x is greater than 100, break. Break is another keyword that can interrupt this while loop. Another action to terminate this while loop. So this is a various ways that you can describe iterations. Various ways of you can describe. So if I say which one is what, then number of times, then that is this. For each inner list, then it's not here yet. That's somewhere, right? One each element in a file, then this is that, and this is while loop. So iteration combined with the conditions. This is a very typical coding flow chart. Given initial state, and then we compare, we evaluate the conditions. If that's true, then update whatever this initial states. So we have updated states that goes into the second iteration. In that second iteration, then there is another conditional statements. If it is true, then goes to another updates and another updates and another updates. That is iteration. And finally, if this condition becomes false, then that is the end of loop. It goes to next block of coding. So example for that is consider 10 iterations, add 1 to 10. So this will work that way, right? You can add 1 to 10. You can make this using while loop. That can be improved. This can be improved in this way. Remember that here, while loop, if that is true, then while true, this works forever. Only this terminates when there is a break. If value is less than 10, then we add up the total number. And then if this value is not less than 10, which is over 10, then end at the value, and then we break that, right? This may be improved somehow. So we can simply say in this while loop, rather than this while loop true so that it goes forever, technically, right? rather than break somewhere, we simply use this condition in this while loop. So while value is less than 10, so while loop becomes shortened, and then finally print. Can be improved that way. So further improvement, rather than using total equals total plus value, we can simply say total plus equal value. This is a simple version. We call this a syntactic sugar. It is like a sugar, so sweet. Syntactically, they are different, but in reality, they are not really different, right? Anyway, this is the same as that. Total plus equals value means total equals total plus value. Same thing here. Value plus equal 1. This while loop can be improved into for loop. Why we use a for loop? For loop, nothing wrong, right? But this specific case, we can make it for loop. So for this, I think we need to practice a little bit. I want to save this into now we want to see for loop versus we increase the values, right? So actually, while value is greater than or equal to 10, then we need to sum them up. So we need to make sum equals 0, and then here sum plus equal value. Value needs to be added there. This value needs to be increased, so that we have to do value needs to be increased by 1. So it'll be value equals 0. What we would do this is very similar to the way that we looked at here, right? Here, say, let's make this from here. I want to make this 0 to 10, very similar to this. So value 0 to 10, but less than or equal to 10, then it should be 11. Up to that, I want to make that, right? So up to 10, I want to add them. Same thing here, up to 10. And I want to make this finally print the sum is format sum. I would say here so if we run both of these, then it'll be this guy is somehow like this, and then sum from 0 to 10 equals to 55. That is this while loop. This while loop can be converted. This is a while loop. This is more like using range and enumerate. Range function and enumerate function. It's not A, but range function or enumerate. And then we want to use a for loop. We can improve this. Let's say this is a last value. I want to say here last plus 1. And then up here global last equals initially 10. We can change this last value. So I use that last value here in this range and then last value in this while loop. So we have a value that gives initially 0. If 0 is less than or equal to last value, that is 10. This is a constant, right? This is a given constant. So use that. And then I want to put here given, last. We can do also first equals 0. Then I want to show to you how we can do parameterize rather than hard coded here. The value previously we put here 0 and 11, but I want to make it parameterized. So value initially that is not 0 but parameterized, so that is first. So that is the first here. Very nicely, so many parameters, so many variables here, right? First and last. With this 0 and 10 number, it remains the same anyway, right? They're the same. But we can change this, for example, from 5 to, let's say, 30. We can change it. So from till 30 here, from 5. So it'll be 455. The sum from 5 to 30, there's a 455. If we want to do here, for example, step, step initially, I want to increase by 1. Here, step. Increase by 1 here. Here a step. And I will make it, they are the same, right? But if I want to change it to every other, step 2, then it'll be changed from 5, so 5, 7, 9, 11, so value increases by 2. So finally it'll be 221. So sum from 5 to 30 by 2. So we need to say here step. I want to rerun. Sum from 5 to 30 by 2. That'll be 221. So that's explained clearly here, right? So we can make this a for loop. For I in anyway we made for loop here. There is a for loop. Yeah. That's a for loop. All right. Let's move further. Some of the practice can be done in this way. For each data type that we looked at, for each dictionary, the key is the name of the institution. The value is the city where that institution is located. So Mercy is in Dobbsbury, MIT is Cambridge, NYU, New York City, CMU, Pittsburgh. So we can print that. So we'll practice that. So I want to make this. Rather than dict, I want to make it campus. Okay. And then I want to print what campus is located where. So we can make this for each in campus and print each. We need to practice step by step. Okay, see what it is. So if we say this campus is a dictionary, each, what I can get this campus, then I can get the list of the keys, right? So we looked at that here. So we can do further. Now we know the key. Therefore, we can say also here campus. Using that key to access, then we use square bracket, or you can say campus.get, open and close parenthesis each. We can do that. For example, for the same thing, we can do campus get each. We can make this. But if you want to use a square bracket, then you can attach to that dictionary itself. If you want to use that key using the method, then you use dot notation like this. And if you want to print, then it'll be Dobbsbury, Cambridge, New York City, Pittsburgh. Either way will work. Now we know where that institution is located. We need to say something, right? Then you can say placeholder is located in the city format. And then you can say each can be located in. I want to use one of those, remove the other. Okay, so first placeholder is each. Each is each campus. That's what each institution, right? And then second placeholder is the city where that institution is located. So Mercy is located in Dobbsbury, MIT is located in Cambridge, and further. So whichever that you manipulate the dictionary, this for loop provides the detailed information very nicely, right? So earlier version of the Python, you need to say here keys, but the recent version you don't need to do. You simply use camp dictionary itself and each, then each can have the key only. Then that is the key. Okay, reading a file. Now we are ready to read a file using our Python. Reading a file is, we do not know the size of files, right? All varies. But we know that is open world, closed world. A book, then it has end of that book, right? So we use a built-in function open. So file name and mode. File name, comma, mode. Mode can be R for read, W for write, A for append, RB for binary data. For example, if you want to read ASCII file, if you want to read images is a file, right? That is not plain text file, but images. Then you need to use RB. If you want to write something into the image files, then you need to do WB. That works. So reading a file, you can print a file as a whole, or you can print a file line by line. Once you open this, print G, then open and print, then it prints entire files. If you want to read line by line, then you need to do for line in G. Remember that line is a variable, local variable. You name it, right? For variable in G. G is file pointer. When you open is a function, right? This is a built-in function. So file is opened. So your program point to that file. Like here, dictionary in your program, then this points to this data type. Very similar to here. Open, you have variable G, then G is a pointer to that file itself. There, you want to make it line by line. When you do open, then make sure that you have a fully qualified path expression all the way to that file name. If you want to use a Windows, then you have a drive number, drive indicator, C drive, D drive, whatever drive, colon, backslash. And then this is a folder expression all the way to file name itself. You need to describe that. If you are using the Mac OS, then Mac OS does not have this. But starting from the top directory, so slash user slash your name slash whatever the file names that you say that. We need to practice that. So print that. Reading a file, we open. This is an example of the files expression. Open expression. So open from here to there. This is a file expression. C colon users jun desktop py string.py. This is a file name in quote. And then mode. If you want to read only, then you can do R. By default, you read. Although you don't say all, if you don't say all, then that means you want to read it, not write it, not write binary files whatsoever. File and read, then you can read entire. File read lines, so all the lines. Split lines, then it'll returns some of the split formats. Then we need to practice this. Okay. What I want to do, I want to open a new file. And then I want to bring up one web browser. And then www.nynewyorktimes.com. We've updated our item. Okay, so which one did I want? What is this? There are many sensitive issues, so we do not want to go into that sensitive, but let's take the article about some zero nonsense article, which is yeah, food is zero nonsense. Is there some food? Good food? Oh, Korean barbecue style. Let's make Korean food. Oh, I have no subscription. Go to another. CNN.com. Why they make this? They ask me to pay. Food or technologies. Where is it? Nobel Prize winners. How to roast Apple Watch series. This is slow. 30 of the best dog. Leave your suitcase. The best deal you can still shop from Walmart. Okay. Click. Click. Slow. Never change. Forget about this. Forget about that. No. Let's simply make it. Sample file. Okay, so I typed it that way, and I want to save this. So I want to save this in the same place that I made. 505. No, in class. And I want to make that here. Sample1.te, sample1.data. You name it, okay? Extension, you name it, and this, okay. And then I want to save. So Python, you don't need to say, but here all. So it'll take my extension and save it, okay? And if you click this, then you can see copy path expression, and come back here. And then you can do reading a file, open and quote. You can paste it, and I want to read it. So this is a path expression. And if you want to handle that file, then you need to hold it, right? So f equals, this open is a function that if the result of that evaluation, that is a file pointer, that file pointer is assigned to f. Let's say fp, so file pointer. And then you can do simply print that file pointer, see what happens, and run it.
Your P is capital letter in the.
Oh, sorry. Thank you. So it returns file pointer. This is file pointer. Okay. So in that file pointer, if you want to read it, fp and read is available in that file pointer, file itself. So if you read it, then this is the file, right? That I just typed. That is read. Or you can read it, print file pointer dot read lines. And if you do this, and lines, it returns 0. I'll explain that later. If you make that comment, and file pointer, fresh file pointer itself, then it returns in a list. Remember that here, list. This is a list. Everything is in line by line. So one line is one element in the list. Here's a quote, here's the end quote, comma. This is a sample file demonstrating how this can be read in a Python code, period, and \n. That is a new line. That's what we created here. Python code, period, and then there's a new line. So new line is comma. This because I said read the lines in a list. So first element in the list is the first line. Second element in the list will be the second line. So that is a second line. And third line, hope here, there. So we have those. That is what this lines is. But if you say here, split lines. Here again. Print fp dot read dot split lines. Split lines. What it does is that fp read returns this, right? This entire file content itself. Into the file content itself, I want to split this by line. That's what it is. Split it by line. This is split lines. This is a split line dot. No. Again. This is file pointer dot read lines. This is file pointer dot read dot split lines. Difference between this and that is this includes new line, special character. But in this case, there is no special character. We simply manipulate it very nicely. That is the difference. Now, why this happens? If I said here, this is a file pointer. When I do this, then it reads from the beginning and all the way here. Initially, file pointer is the beginning of this content. And at the end of this read, file pointer is pointing to the end of that file. That is the reason. If we have, once we have this, then whatever that we have next, it'll be empty. Right? Like this, then that is empty. If we open this, I want to have 3 print statements, then I have 2 of those. Because a file pointer already reached to the end of this file. How can we bring back to the beginning? That is this file pointer dot, then there is a seek method. I want you to find out from that dictionary, help. And then if you put 0, then, hey, I want to go back to the first, the beginning of that the file pointer. So if I do this, then first time it reads everything, and second time it reads read lines, and third one is still empty. So I have to do this every time it reaches. Then I have to do this. Then everything will be okay, right? If I do here, now go back to the first, maybe 10 points. Then it goes to, see here, look at this. This is entire content, right? The third one here, I do not rewind all the way to the beginning of that file. I rewind it to the point 10. So 10th character. So it starts from simple, here, somewhere here, right? Simple file. So if you count from here there, then I think that is 10 characters. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 character. It starts from 0, so 0 to 10. So this is the 11th. S is the 11th. So it goes there, right? In this way, it runs, right? So if you want to use a for loop, then we simply use from the file pointer, not directly say read, but we want to see here for line in file pointer, and then print line. Then we can do. Let's see. I think we still do fp.sig 0, and here because it's not really what I want to do here. Enumerate, and then here line counter, and I would say I, so 0, line counter 0, and first line is this is the line, and second line is that, and third line is that, right? That's what it is. So if you want to make this real lot nice way, then you need to do, you know what you can do, right? You can do line number 1, and then right. In this way it is line number 1, this is a line number 1, this is a line number 2, and line number 3. And then you can do so this is a line number 1, contains a list of words. So we split the words, split each line by word. So in the first line, this is the word, is a word, a is a word, simple, sample, file, demonstrating how this can be read in a Python code. This comes from the line 1, and then line 2 and line 3. If we want to make it real nice, then we need to make print, and print, I want to make 30, and after this I want to make print A little bit of a decoration. Decoration is like this. This is line 1. Contains the words like this, and end of line 1, and this is the second line, end of line 2, and end of line 3. The code is this. Very simple code, right? Any question about this code?
No, none so far.
Great. I think this is it for today. So next thing that you need to do is to do the homework assignments. Therefore, you can practice a little further comparison or whatsoever. Yeah, let's put here some of the conditional statements. We didn't do conditional statements yet. So what we need to do here, I want to split this and then word list equals the split. And then I want to make print word list. And then I want to make another for loop. Each word in word list if I want to find the is. Okay, there's word. There are many words there. Nope. Why? Nothing found.
The if statement, I think you put is instead of in. So if is in WD, you put
No,
is.
W is a word itself.
So the
So
second.
yeah, I know. Yeah, this is word itself.
Okay.
Let's see. This is not. I know what you mean by that. If this is a list itself, then you can say in. But
Okay.
is. Let's see. What we will do here, print word. Then we may be able to see. There is a word. Or another, we'll find out. The length of the word is greater than 4. Then we can say long word is found. Let's see if it works. Oh, we don't need to say that. Yeah, anyway, it's found some word, right? So long word Python is found, long word example is found. If we can increase this to 6, even longer. So example computer, those are the found. If you want to even longer ones, computer manipulated, understand, those are found. This is characters something. When we compare with that, then I think somehow there's a white space in. I'm not sure why. White space is removed here. Maybe, yeah, we'll look at that later. But anyway, this is something that you can do if statements within for loop, and then for loop can be nested, as you can see here. For loop contains another for loop, which contains the conditional statements. So this is a very nice example that you have. All right, this is the end of today's lecture, and I will see you next week. Yeah, quick correction here. This is a little bit of a magic. This word, if we say here is equal word, then nothing is found, right? But if you change this, the left side is word variable, and right hand side just a string, then it works. Here is a found, right? So you can say here WD is found. Then here is found. Only one case. But if you say here A, there is a more. So here A found, A found, A found. Here 2 A's found here. 2 A's found, 1 A found, and 2 A's found. But for example, if we here for A is in word list, print A found. I want to make this comment from here there. So in is this is an element in the list. Whether element is in a list, and we can say A is found. If we make this, then not for, we say if A is in the list, then print Then what it does is that once it is found, then we can say it is found. It doesn't do if we use a for loop, then we know how many matches there. In this case, only if it is found, then we can say found, right? That's what it is. Whether it is found or not, if we do this, okay, rather than how many occurrences. In this for loop, we can see how many times it is found. Here, 2 times found, 1 time found, right? Because this guy compares all the occurrences in this for loop, rather than simply check the existence. I think this is some of the addition after that.